Bismillahirrahmanirrahim. Dear students, I am Ahmed Mumtaz Mustasin. I have been given the responsibility to teach you CSC 322 operating systems concepts. I think I have already taught one course before, CSC 141 Introduction to Computer Programming, and that course is incidentally the prerequisite of this particular course. So the students who have already studied from me the CSC 141 Introduction to Computer Programming, they must be knowing me very well. Anyhow, if you like, I can give you a brief introduction. I've done my master's in computer sciences in 1979-81 from Quaid-e-Azam University, Islamabad. Then I did my specialization in satellite image processing from Paris, France. It was basically a 3-year defense project where I was supposed to take up the major responsibility to develop the Earth to satellite interface, complete interface. So you can imagine that I've got 30 years of experience, rather more than 30 years of experience, and during these periods I've been almost in touch with the education and most of the time doing in the research and development environment. So I've served many national and international organizations started as a lower management, then obviously with the passage of time I also served as a top management. Presently, I am engaged with the ComStats Institute of Information Technology, working as a General Manager IT. I have quite a good experience handling the operating system. In fact, in 1982, I developed the first MON-based control program that provided the end users the interface to work on the computer. It was basically a monitor program along with a basic language interpreter. So I've developed quite a lot the system programs. So I've done system programming and cryptography also. That's a bit tricky and specialized field. In most of the time I've been developing in the assembly language. Fortran language and C language is also one of my favorites, and I've done a lot of development in C and Fortran as well. So I have also contributed a lot of projects of our national interest, mostly in the area of defense. So with this, I think let us introduce the course which I'm supposed to teach you. It is CSC 322 Operating Systems Concept. It's a 3-credit hour course. So 3-credit hour means by this time you must be knowing what is a 3-credit hour. So the 3-credit hour means 3 hours teaching per week. So you are supposed to listen to me, my lectures, at least 3 hours per week. And then you expect that when you are listening the couple of lectures per week, you need to spend quite a lot of time going through the material that I will provide you, or I will refer it to you. Objective of this course is basically this is a most fundamental course of the computer sciences, where we introduce the fundamental concepts of operating system. Different models of operating system will be introduced. The references and examples that I'll be quoting most of the time is from Unix, few examples from Windows, and also I have worked on virtual memory system, VMS operating system, so I might find it more convenient to give you the examples from the VMS. And then there is a traditional operating system which is called Multics operating system. So we'll be talking about the Multics also. There is a very latest concept in the modern operating system, and that concept is the abstractions. What does it mean? The abstraction. Abstraction means to provide you a mathematical model, to provide you some logical model, to provide you something which is not real, but in order to explain something, we take up the help with the help of mathematics, or with the help of certain logic, or with the help of certain basic instructions. So when we say that the abstraction of CPU into multiple processes means that how does the CPU serving different processes, or the abstraction of memory, the physical memory, into virtual address space. If we explain that in terms of the abstraction, so the student would be able to understand it better. Another good example is the abstraction of disk into the files, because the user deals in files, whereas the disk provide you the storage onto the file. But the student, the users, the faculty, anyone who is using the disk is looking into the disk as if he or she is handling a file. So basically, the abstraction of the disk in the form of the file. So lot of concepts are within this particular abstractions. So the students will be familiarized with the different operating system structure models. There are 2-3 basic structure models, and then there are certain hybrid models, which are the combinations of these models. The basic responsibility of the operating system is to provide certain facilities, certain functionalities. And these functionalities, if we split it up into form of the modules, then we can say that there could be certain modules, for example, process management, memory management, device management, or I/O management, file management. All such type of modules will be discussed. We'll also talk about the protection and the security mechanism that is embedded into the operating system. How does the operating system extend or abstract the protection and provide you the security of your data, the security of all type of services which are provided to the users, by providing the security of the data and the information that has been shared and provided onto the computer for processing it. We will take up a few case studies, maybe at the end, and in this case studies I will pick up a few operating systems, Linux or Unix, Windows, or maybe any embedded system, or any mobile operating system. We'll take it up and cover it up as a form of case studies. So I'm skipping here the course outline, because I will provide the detailed course outline in the form of the lecture breakup at the portal. So I invite you to please visit the portal, visit the course portal, and find out all the details that I have provided over there. Quickly, the book, the textbook that I strongly recommend is the Modern Operating System, 3rd edition by Andrew S. Tanenbaum, one of my favorite author. And I've been teaching this operating system for around almost 28 years. But for the last 10 years, I picked up this author, and I liked the way the author explains the complexities of the operating system with a very simple and day-to-day examples. The 3rd edition mostly available, but if you don't find the 3rd edition, yet the 2nd edition also covers the most of the course that I'm supposed to cover up in this particular program. The major difference between the 2nd edition and the 3rd edition is the latest concept of abstraction. Whatever the explanation the author has provided in the 2nd edition has re-explained it in the form of abstraction. So he found the abstraction, another way of explaining the same fundamentals, the same concepts that we taught and we have been teaching for the last 10 years. But this time we will explain it by taking a slight latest concept, which is the abstraction. Few more books that you may find. Once again, another book by Tanenbaum and his companion Woodhall, and that is the Operating System Design and Implementation. Then our well-known author Dieter, and we have already used the Dieter and Dieter book in our Introduction to Computer Programming course also, but this time it's an Introduction to Operating System. It's a more application-oriented, example-oriented, where the examples from the Unix, OS/2, MS-DOS, and Windows or the virtual machine have been provided. So I'll pick up few examples from that particular book in order to explain some concepts as and when required and wherever are required. Also, another reference, I would like to thank the author Tanenbaum and its publisher Printers Hall, from where I have picked up the lecture material. Not 100%, but I have picked up the lecture material, gone through it, and then I decided to update it according to my own satisfaction, and certainly I have added lot more information onto these lecture slides. But the basic material I have picked up from the official website of our textbook and the publisher from the Printers Hall. I'll give you the URL also, and that URL is provided on my course portal. We have intention to cover this course in 32 lectures. That is almost the standard. Minimum 4 quizzes, all carrying equal marks. 4 assignments, again all carrying equal marks. 2 midterm examination. Rather, there are 2 examinations. One is the midterm and one is the terminal. But let us see, we might go for sessional 1 and then the sessional 2 and then the terminal examination, or we'll see that whether we will conduct 1 midterm examination. I'll update you later on through the course portal or maybe in my subsequent lectures. So I will also like you to have some practical exercises of this operating system. So I'll be explaining you how can you have certain practical exercises on the operating system, and if time permits, then I might also be giving you some demonstration, some practical demonstration of the operating system. So with this, let us start formally the first lecture on operating system. So as I already thanked the publisher and the author, so we'll start this introduction to operating system, and that is the first chapter of Modern Operating System, 3rd edition. Dear students, the basic question, what is an operating system? I think we will keep on defining and keep on improving our definition throughout this course. In order to explain operating system, I need certain concepts. And these concepts to explain, I need some more concepts to explain. So, don't worry. We will start with some initial definition and then keep on improving this definition from time to time. Basically, the computer system comprises a lot of devices. You might be knowing the most common device that the computer has, your LCD screen, the keyboard, the mouse, and some devices which you find inside the CPU box is the central processing unit, processor itself, main memory, disks, and also if you need some hard paper printout, you need the printer also. So basically the operating system is responsible to manage all these variety of devices, all these variety of components that constitute a machine which is called operating system. When the operating system manage or operating system facilitate the end user in managing or handling these devices, then the operating system basically is composed of set of instructions by itself, which is a software. So operating system is nothing but a software that takes up the challenging job of handling the variety of components of the operating system. How it does that? First of all, the operating system by itself is considered as a layer. Layer of what? Layer of software. So operating system is a software that is organized in the form of layers. I have already said in the beginning a term abstraction. So basically it provides user programs, in fact the users, with better, simpler, cleaner model of the computer and handle all the complexities, handle and manage all the complexities of these components or these resources. What does it mean? It means that the operating system directly handles the components, directly handles the devices in the form of the instructions, communicate with these devices, and hide these complexities of handling these devices in itself and present a very simple picture to the user, to the end users. And what are the end users? End users could be the user programs, application programs, or interactive users. As I said in the beginning, we need to define what are the application programs and what are the interactive users, but in the beginning we can say that the user programs are facilitated by another program which is called the operating system. So the operating system facilitates the users by facilitating their programs. The interface that the operating system provides to the user is either a shell, means a command-based. Command-based means you are supposed to type and remember the command with all its qualifiers and all its minute details. So once you type in these commands basically are converted into the form of certain instructions of the operating systems, and then these instructions take you towards the devices and facilitate you. So basically these commands are provided to the end user through a shell. So we have got multiple shells available. It's just a concept where you type in your command. But we have seen the kids, a 3-year kid, a 2.5 years kid, sitting on the computer playing games. How is it possible? Because another interface which is called graphical user interface. You may pronounce it as GUI, G-U-I, graphical user interface. It's the simplest interface that could be presented to the end user. And this interface doesn't require that the end user should remember any command. The end user can simply pick up any graphical pictorial icon, a picture, simply double-click that mouse. The command is embedded with that particular icon or with that pictorial, and once this icon is double-clicked, the command is automatically activated and the operating system service started to provide the service to the end user. So if you want to play a game, simply find out on the screen in a graphical user interface its icon, and it's self-explanatory most of the time. You just need to identify that this is your desired icon. Take the mouse to that particular icon, double click that, and your game is loaded and executed. So simple. So we have got different types of graphical user interfaces. Why? Because for every operating system, you have got one graphical user interface. Although the Windows, which is the product of Microsoft, try to keep the same or the similar interface for all different variety of operating systems introduced and provided by the Microsoft. But yet there are few differences. Then we have a Linux, free BSD. It is also some sort of Unix, and Unix is also an operating system, as I said in the beginning, and we'll be referring most of the time the Unix commands also. VMS is a virtual memory system, operating system. System 5 again based upon, inspired from Unix and Linux. Solaris is mostly Unix-like operating system, and it's copyrighted by the organization who call it as a Solaris. So basically these are the different examples of the operating system. So how do we organize, how do the system is organized? We can assume that hardware is the bottom. Hardware is at the lowest level of the computer system. And this lowest level, we said, that comprises all the devices. Or if you just want, you can just extend these devices into the form of the components. You can say the chips, and then few wires. And basically these wires constitute a device which is called a bus, because these wires or these ribbon wires or these channels basically takes the data from one component to another component, from one device to another device, and I will explain it to this later on. Then the software is further split up into the layer. So we split up software in two modes. One is called a kernel mode, which is a privileged mode, which is a protected mode. In this mode, a complete access of every instruction available on the computer system, every instruction of the instruction set of that particular architect of the machine is available to the operating system, and operating system can execute any instruction that is the part of the instruction set. No restrictions to the operating system, because someone has to execute that, and it is the operating system that execute every instruction available, but in a protected mode, which is called kernel mode, protected from the user. So where does the user program execute? Certainly the user programs are executed in the user mode, and this user mode has lot of restrictions. Means this user mode is not allowed to interfere with the kernel mode instructions. What does it mean? It means that only subset of instructions are available to the user in this particular mode. Especially the instructions that communicate with devices, I/O devices, or instructions that are for the memory protection, for example, are forbidden for execution by the users. So we provide a user a restricted instruction set, or the instruction set which are very safe, so that the user may not harm the machine or may not interfere with the data of another user on that particular machine. So all these concepts I will keep on explaining from time to time. By the way, please remember that the first few lectures or the first chapter is an introduction to the operating system. So I might be touching certain concepts and might not be explaining it in detail, because in the subsequent lectures we will pick up one by one each concept and go into the detail of that particular concept. So while I'll be introducing the operating system, so I'll be covering up memory, I/O devices, CPU, file systems, security system, system calls, all those technicalities and the functionalities of the operating system will be introduced. But later on we will pick up in the subsequent chapters one by one the more detailed version of each and every concept. So please don't worry if you do not understand all the technicalities in the first chapter in journal and in today's lecture in particular. So whatever I have explained it to you, you can see that on the bottom we assume all the hardware in the form of devices or in the form of components. Over that we have the layer of operating system, which execute in a mode called kernel mode, and then over and above that kernel mode there is a user mode. So there are basically the four layers which are being introduced here. The bottom layer is the hardware. Over that there is another layer which is the operating system layer. Over that you can find there are two more layers available: user interface program and the user mode, topmost the shell or the graphical interface. So you can see all the complexities, all the details, technical details are hidden from the operating system. So operating system present a user an interface, and I have already explained it to you. This interface is a shell, or this interface is a graphical user interface, GUI. That means you have a graphical icons available for the web browser. If you want to browse an internet, select any web browser, Explorer, Google Chrome, or any. There are quite a few browsers that are available. Then the email, so you can use Gmail, Hotmail, Webmail, or you may have your own customized email provided by your institution or provided by your organization. You can also play any video or audio by picking up the music player or the audio player by simply double-clicking that without going into the technicalities. So the end user has got a very simplest form of the operating system or the operation of the computer, and that is thanks to the operating system that provide this simplest form to the end user. How it works basically. As I have already said, that the operating system basically is a layer. Similarly, we have got the user program that is over and above, and the usage of the computer is through instructing the computer in the form of software. So there is a difference between the operating system software and the user software. We go back to the previous slide and we see that there is a difference between the operating system software and user program software. Operating system user program software execute in the protected mode, which is a kernel mode, and the other one is the user software layer, which is basically the user programs that execute over and above this one. So let's move forward. We would like to talk about the difference between the operating system and the user software. One very simple difference between the user software and the operating system is that if you do not like a piece of software, for example, if you do not like that the Hotmail or the music player from provided by the one vendor, you can discard it. You can use the music player of another vendor that has been provided. Or you may write your own music player if you are capable, or if you are a programmer, or if you are a system programmer. You can write your own piece of software instead of the piece of software that has been provided to you by the operating system or facilitated you through the operating system. But on the other hand, if you do not like the interrupt controller, the clock interrupt handler, for example, and you want to write down your own, no, you cannot do that, because this clock interrupt handler is protected by the operating system. It is in a protected mode. So that's the major difference, that the component of the operating system which is provided by the operating system, you as an end user cannot modify that and cannot change that. However, the over and above, the top layer application programs which you are using, you are free to change it as per your convenience and as per your liking and disliking. So, is there any boundary between the kernel mode and the user mode? Although we have shown a boundary between the user mode and the kernel mode. But there are a number of operating systems where certain programs which are the part of the operating system but not executed into the kernel mode. For example, I can give you the example of the file system. In some operating system, the file system module is executed into the user mode. Another example is the passwords. So you can change your password, you can use this password to provide the authentication to the operating system that you are the valid user. So this password is executed into the user mode, although it's a very important and very sensitive component of the operating system, but it executed into the user mode. So how can we draw a boundary between the user mode and the kernel mode? A simplest way we can say that whatever is executed into the kernel mode is nothing but the operating system. आसान बात है कि whatever is executing in the kernel mode is 100% operating system, and whatever is executed in the user mode, it don't necessarily everything is the user program. ठीक, reverse true नहीं है. इसका मतलब ये है कि whatever you are executing in the user mode, it could be the user programs, and even it could be some sensitive programs which are the part of the operating system. Okay, another difference that we can see between the user programs and the operating system is the size of the program or the size of the operating system versus the size of the user program. This is not very uncommon to have the operating system like Windows or Unix having 5 to 10 million lines of code. 5 to 10 million lines of code. How can we interpret that? Suppose on one page we write down 50 lines of code. Then we can have 1000 pages. So 1000 pages will constitute one volume that will have a 50,000, 50 multiplied by 1000, 50,000 line of code. But I said that there could be 5 to 10 million instructions per operating system. So you will have 100 such volumes that will constitute 5 to 10 million. 100 volumes of code, each of size 1000 pages, and each page contain 50 line of code. So you can imagine how big the operating system is. So that's why the operating system is usually, whenever this operating system or any operating system is produced, that operating system remains available for quite some time, because changing that operating system is not so simple, and it's not the job of 1, 2 or 10 person. Usually hundreds of people join their hands together to produce one commercial and one professional operating system for the users. So that is again a big difference between the program written by the users and program written by the written as a operating systems, or written as a utility. Even the Window Explorer and a few more utilities have almost the same volume, but sometimes even the bigger volume as compared to the operating system. So we are just defining operating system. हम कोशिश कर रहे हैं कि मुख्तलिफ flavors और मुख्तलिफ aspects of the operating systems जो हैं वो आपको explain करते चले जाएं. So if we say that what type of functions an operating system is supposed to undertake, so we can say that there are two types of functions that the operating system is supposed to undertake. Types कहें, category कहें, whatever, two different sets के अंदर हम उनको break कर सकते हैं. One is called abstraction, means providing application programs or application programmer a clean abstract of resources instead of complex hardware. पहला काम तो स्ट्रेट फॉरवर्ड है कि जितनी कॉम्प्लेक्सिटीज हैं, जितनी भी डिफिकल्टीज हैं, उन तमाम डिफिकल्टीज को अपने अंदर समो लेना है. ओके, उन तमाम कॉम्प्लेक्सिटीज को खुद हैंडल करना है और यूजर को एक बड़ी सिंपलेस्ट रोजी पिक्चर पेश करनी है, so that a kid of 3 years should also be able to use that machine. But if we extend all the complexities of the actual complexities of these devices and these components, then nobody is going to use your computer. Nobody is going to use in the general public. Obviously, very few programmers, professionals would be able to use it, but not the general public, not the millions and billions of people who are presently using their computers. So this is the first functionality of the operating system, to hide all the complexities in it and present the simplest form of interface to the end user. Number 2, manage the resources. अब कौन से resources? Obviously, it is hiding those resources from the end user, means the devices, means the CPU, memory, disk, all types of I/O devices. So basically the system is supposed to manage these resources also. How it does that? You can see that once again on the bottom of the hardware, bottom of this model is the hardware, and handling this hardware is very ugly. So it has got a very complex interface. So managing this complexity is the responsibility of the operating system. So operating system which is over this hardware is basically hiding all this ugliness, all these complexities within it, and presenting a beautiful rosy picture to the end user. So आप देख सकते हैं कि ऑपरेटिंग सिस्टम जो है वो तमाम अगलीनेस को, कम्प्लेक्सिटीज को हाइड करता है और प्रेजेंट करता है रोजी पिक्चर टू द एंड यूजर, simplest and easiest picture to the end user, or end user could be the user programs or the user themselves. So this abstraction is done by defining and implementing the abstraction. First of all, operating system define the abstraction. मैंने ये करना है मैंने इस इंटरफेस को ऐसे प्रेजेंट करना है. दिस इज कॉल्ड द डिफाइनिंग द एब्स्ट्रैक्शन. वंस डिफाइन द एब्स्ट्रैक्शन, तो फिर वो काम करना भी पड़ेगा, because you have decided to do that. So the second task within the abstraction is the using the abstraction to solve the problem at hand. Means कि आपने कहा कि एक complexity जो है, जो ugliness है, उसकी operating system की, let me see whether if I can explain it to you. The top of the hardware means you can find some ugly pictures. So operating system decided that I'm not going to give this ugly picture to the end user, although it's very ugly to handle this hard disk, but I'll present my hard disk to the end user as a file. It's not the responsibility of the operating system to go to the end user to go and handle the complexities of hard disk. The user should simply say that save this file onto the hard disk, and the system should be able to save that. But who is going to handle the complexity? That complexity is handled by the operating system. So, in the abstraction, whatever I have explained it to you, operating system hides the hardware and present the program with a nice, clean, elegant and consistent abstraction to work on it. अब समझ में आया मतलब एब्स्ट्रैक्शन का, कि तमाम कॉम्प्लेक्सिटीज को हाइड करके एक रोजी पिक्चर प्रेजेंट करनी है टू द एंड यूजर. सो द ऑपरेटिंग सिस्टम टर्न द अगली इंटरफेस इनटू अ ब्यूटीफुल इंटरफेस. And these interfaces are already available. The examples are Windows. I think every one of you have seen that, might have seen that and should have seen that. Windows GUI, command line, both running on the Windows operating system and providing this such abstraction. The same abstraction is also available in Unix or in Linux, or Linux में इसको कहते हैं GNOME or KDE. These are the graphical interface available on the Linux. So this is different from the Windows, but it sees a very different interface than a Linux user working on it. Text oriented. If you are the X-Windows user, or if you are the shell user, then you are supposed to learn all the commands, and then you need to type each and every command with all required technicalities and detail. So maybe I will demonstrate it to you somewhere if I just could arrange some demonstration for you. So one of the tasks that the operating system is providing is the abstraction. So we say that the operating system as an extended machine. Why it's an extended machine? Because operating system has extended the lower end of the hardware to the top end, extended it to certain height by hiding the complexity, and extended it for the user the simplest interface. तो हम इसको कहते हैं operating system as an extended machine. So you remember this was the major role, the first role we talked about that the operating system is supposed to undertake. So the operating system as an extended machine and the operating system as a resource manager. ये दो functionalities हमने operating system के बारे में बात की थी. So we have already seen the operating system as an extended machine, and what does it mean? Let's talk about the operating system as a resource manager. Oh, I've got still few examples regarding the operating system as an extended machine. So before take up the second explanation, as a resource manager, let us talk about with the help of an example, what does extended machine means. The architecture of the computer system, which is usually the instruction set, memory organization, I/O, bus structure, of most of these computers is difficult to program at machine language level. Especially handling the I/O devices is very complex and very tricky. So I can give you an example that suppose you want to carry out a read and write command to a floppy disk. We have taken the example of the floppy disk because floppy disk later on extended, वही concept जो floppy disk था, disk का जो concept था, was extended to the hard disk. We can say that the floppy disk has just one plate with two surfaces, and hard disk we have usually got multiple plates and multiple surfaces, more complex than the floppy disk. But in order to explain the concept, it's a good way to pick up the example of floppy. If we are required to carry out a read and or write operation at the floppy disk level, we need to pack 13 parameters into the 9 bytes. 9 bytes का मतलब, if there are 8 bits, so there are 72 bits, and within these 72 bits you are supposed to pack these 13 parameters. These 13 parameters means you want to read, you want to write, what is the address of the buffer, where you want to read in, what is the address of that particular floppy, from where you are supposed to read that particular data, what is the inter-sector gap, what is the packing density, and what are the other details of that particular mechanical device, that you need to provide all such details. And after completing this read-write operation, the system, the device, returns 7 bytes. But these 7 bytes hide hides in itself 23 status and error fields. क्या मतलब? 23 status and error fields are packed into the 7 bytes and returned back. So obviously the user need to interpret those 7 bytes. And in 7 bytes try to find out what are the status. What is the condition, whether it was successful or not. If successful, where the data is. If not successful, what was the reason, and a lot more. In addition to these parameters, the operating system also required to take up the decisions of what? Decision whether the floppy should be keep on rotating. The motor that rotates the floppy, RPM, how many RPMs. So obviously a floppy has got certain RPM. So you have to take the decision, means the operating system has to take a very tricky decision. If the floppy disk is not rotating, it's silent, okay, then in order to read the data, first of all you need to energize that motor. It will rotate that, and once that number of RPMs are achieved, then the head will move to the desired location and we read the data. So that will take a lot of time because it's an electromechanical device. So the quick way of resolving, saving the time is you keep the floppy rotating all the time. Can we do that? No, we cannot do that. It will tear out the surface of the floppy disk. When the motor will heat it out by itself, and also of the rotation of the floppy at a constant speed for a longer period of time. Obviously, it's a very fragile material, and that fragile material, if you keep on rotating this, it will tear out by itself. So the floppy disk will tear out if you just keep on rotating the floppy disk throughout the operation of the computer. So you need to shut down that motor. You need to switch off that particular motor. So it's a tricky decision that the operating system needs to take, whether the floppy should be kept rotating or whether it should be motor should be switched off. So what abstraction the operating system is providing to the end user? So user doesn't know that there are so many complexities, so many details are required by simply just reading a file from the floppy disk. So the abstraction for the user is that a simple file has been stored onto the floppy disk. You go open up the folder in GUI, you simply click that. It will start rotating by itself, provide you the folder. You click that particular folder of the floppy disk. It gives you certain folders and certain information, certain files. And you pick up the file, double click that, and it will open up the file and provide you onto the screen. But mind it, for carrying out one single operation, how much complexity that the operating system is supposed to undertake. So that is the major topics that we have to study in this particular course. The next functionality of the operating system is operating system as a resource manager. The abstraction is a top-down approach. User को क्या नजर आ रहा है? User को floppy disk की कोई complexity नजर नहीं आ रही. User is looking at the floppy disk और abstraction में user को एक file नजर आ रही है उसके ऊपर, simplest form. So the abstraction is a top-down approach. But the managing of resources, अब resources को manage करना है, organize करना है, is a bottom-up approach. So abstraction आ रही है top-down और managing the resources is the bottom-up management taken care by the operating system. What are the resources basically? Resources are processors, memories, timers, disk, mouse, network card, printer, variety of resources are available. All modern operating systems to provide and controlled allocation of these resources to multiple programs which are running at the same time. This is the responsibility of the operating system to allocate the resources to the programs which are using it. So let's take a very interesting example. Suppose 5 to 10 users are using one computer at one time, or you can say that 5 to 10 programs are being executed onto the one particular computer simultaneously. Each or 80% of the program or 80% of the user wanted to use the printer. At one time, the CPU is allocated to one user, resources allocated to one user. Obviously, you need to allocate the printer to that one user. The user will write down and process the data and print out something onto the printer. Then the CPU is taken and another user takes over the resources. Few lines will be printed by the second user. Few lines will be printed by the third user. So it will all hosh-posh, mix up, jumble up the output onto the printer. पता ही नहीं चलेगा कि किस यूजर ने क्या चीज प्रिंट की, सब मिक्स अप हो जाएगा. So this is the responsibility of operating system. So how does the operating system solve this problem? A very simple concept which is called buffering. Operating system provides an abstraction of the printer to the user. User assumes that he is writing onto or printing onto the printer, but the data is printing somewhere in the memory, somewhere in the file, wherever the application has been provided. And once the file is closed, once the file is completed, then it sends the complete file by allocating exclusively that particular printer to one user. So at one time you find out one single printout of one user. So that hosh-posh or mixing up is not there. But for the end user, someone has done this job. Someone has managed the resource of the printer for 6 to or 5 to 10 users. And this task has been undertaken by the operating system. So the second concept, that operating system as a resource manager, I hope you have understood that. I have already explained this. Similar to the printer, where you can assume the I/O devices also, that there could be number of users, and you might have handed over any I/O device, because the printer is also an I/O device. So you can very well understand that how in the previous example I have explained it, that the operating system has managed that. So we can say that the primary task of operating system is to keep track of programs and users using resources. So operating system grant these users the resources and then take back these resources. These users might have some conflicting requirement, some conflicting request, and then the operating system is required to undertake that responsibility, that these conflicting requirements should be managed such that one user should not interfere with the data of another user, or information from the one user should not be passed on to the other user. So this is because the resource means device, and the data is also a resource, information is also a resource. Sometimes users are sharing the information, so you have to be very careful that how this information should be shared among the user. I'll explain it later on, maybe in the next few lectures, with the example how critical it is to share the information between multiple users. So we have seen that the operating system manage the resources. Operating system manage the resources once again in two different ways. We call it as multiplexing. Multiplexing means distributing the information to the distributing these resources to the multiple users. So the resource management is done with the help of multiplexing, means sharing of resources among different users. So two ways. Number one is time multiplexing. In the time multiplexing, the resource is exclusively handed over to the end user. For example, the CPU. CPU at one time is handed over to one particular user. When the time slot is finished, the CPU is taken back and handed over to another user. So who goes next and how long is the task of the operating system. अगली बारी किसकी है, अब किसको CPU allocate करना है और कितनी देर के लिए allocate करना है. और CPU की allocation जो है वो टाइम मल्टीप्लेक्सिंग है, और टाइम मल्टीप्लेक्सिंग में मैंने आपको बताया टाइम दिया जाता है, टाइम स्लॉट एलोकेट की जाती है, और मैंने आपको बताया कि ये एक एक्सक्लूसिव एलोकेशन है. एक्सक्लूसिव का मतलब है कि कोई और उसको शेयर नहीं कर रहा. होल रिसोर्स हैज बीन एलोकेटेड टू वन यूजर. और इसकी एक्सक्लूसिव एलोकेशन की एग्जांपल मैंने आपको प्रिंटर की भी दी थी, जहां पे एक्सक्लूसिवली एक यूजर को दे दिया गया था प्रिंटर, एंड द job was printed onto the printer, and then the printer was exclusively allocated to another user. अगर एक प्रिंटर को एक वक्त में दो यूजर्स को एलोकेट कर देंगे और दोनों यूजर्स साइमल्टेनियसली प्रिंट करेंगे, तो मैं ऑलरेडी एक्सप्लेन कर चुका हूं कि उन दोनों की आउटपुट जो है वो मिक्सअप हो जाएगी. सो कुछ डिवाइसेस का मिजाज ऐसा है, उनकी कैरेक्टरिस्टिक्स ऐसी है कि आपको उसको एक्सक्लूसिवली ही एलोकेट करना होता है, कैन नॉट बी शेयर्ड. But there are certain devices which can be shared also. For example, the devices having the space. So, if the space is being shared, this is called the space multiplexing. This is not exclusive allocation. At this time, you allocate one certain location to one particular program or one particular user, and one chunk of space you allocate to second user. But for allocating the space or sharing the space among multiple users simultaneously, you need to have some protection mechanism. You need to protect the information of one user from the other, and that is usually provided in the hardware. So main memory of the computer, you can simultaneously put in quite a few programs at one time into the memory. Maybe 10 programs or maybe thousands of programs, depending upon the operating system, depending upon the computer. But we can say that the multiple programs can simultaneously be present into the memory of the computers. Or we can say one program can split up into multiple tasks also. I will explain it this later on. So the main memory among several programs, more programs in the memory, similarly the hard disk, multiple users sharing the same hard disk. So there should be some mechanism on the hard disk as well, so that the one user should not interact or should not unintentionally or intentionally pick up the information or the data present for another user on the same hard disk. This resource management should be done with some principles. कुछ असूल तय करने चाहिए कि resources जो है उनको कैसे allocate करना है among the users. सबसे पहली बात तो fairness. There should be a fairness among all the users. Okay? If all the users are of same category, if they do not have any priority among themselves, then you need to allocate the resources with all fairness. ऐसा ना हो कि एक प्रोग्राम तो सारे का सारा CPU कंज्यूम कर जाए और दूसरा यूजर जो है वो बैठा रहे और उसकी बारी जो है वो बहुत देर में आए. This is unfair. So you have to have certain principle so that each and everyone should get the resource whenever it is required and should not be kept waiting for a long time. Second one, we have already talked about it, the security. Users should not interfere with each other and the data of each other. So you have to keep their privacy of their data and the security of their data and information. Then, as a computer system, if you do the fairness, if you do the security, if you just allocate these resources, then your objective should be to optimally utilize the resources. ऐसा ना हो कि एक रिसोर्स तो बहुत ज़्यादा यूज़ हो रहा है, प्रिंटर तो दबा प्रिंटिंग किए जा रहा है, but the CPU is being wasted. तो you need to mix up different programs. आप इस किस्म के दो प्रोग्राम्स को मिक्स अप करें कि वन प्रोग्राम इज CPU बाउंड जो मैक्सिमम CPU को यूज कर रहा है, एंड वन प्रोग्राम इज IO बाउंड और यूजिंग द इनपुट आउटपुट डिवाइसेस, सो दैट के IO डिवाइसेस भी यूटिलाइज हो जाएं और CPU भी यूटिलाइज हो जाए प्रॉपरली. So with this we have completed the basic functionalities and the introduction. I will now just quickly go through the history of the operating system. I will advise you to please read it out, but certainly it's a very interesting history, so I would like to spend some time explaining the history of the computers also. The first digital computer was thought of, we say that was designed, but it was just basically thought of by an English mathematician called Charles Babbage way back in 1792 to 1871. This was the era, the time period of the date of birth of the Charles Babbage, 1792, and he died on 1871. He, in his life, tried to build up an analytical machine, and that analytical machine was basically the idea that has given birth to the computers. उसकी जो analytical machine थी उसमें वो तमाम features देखना चाहता था जो कि बाद के आने वाले computers में मौजूद है. But the problem was that he was not successful just because he tried to build up that particular machine with the help of mechanics. It was mechanical engineering which he selected to produce the analytical engine. So obviously it was never there, or he was not successful क्योंकि mechanics में इतनी power नहीं थी, इतनी flexibility नहीं थी, इतनी support नहीं थी कि वो अपना analytical engine बना सकता. But some concepts that he had introduced, he quickly realized that it's not just the mechanics that should be able to provide the or produce or invent the analytical engine. He thought that there should be some instructions also. कुछ इंस्ट्रक्शंस भी होनी चाहिए जिनकी मदद से इस मशीन को एग्जीक्यूट किया जाए. So that was a wonderful idea. And that instruction, or the set of instruction, nowadays we call it as a software. So not only he thought about it, but he hired a young lady, incidentally the daughter of the very renowned poet Lord Byron, who was also a British poet, and his daughter was Ada Lovelace. She was hired and she was asked to produce those instructions. She attempted that, and she was not although successful for the analytical engine, but subsequently when the computers were launched, she was the first lady who produced the computer language, and that language was renowned on her name called Ada. Ada Lovelace के नाम से उसको Ada का नाम दिया गया. So if we broadly split up, कोई hard and fast rule नहीं है, for our convenience, we have split up the generations of the computer in 4 categories. 1945 to 1955, it was the electronic era, where we used to have the vacuum tubes. Then came the transistors, so that have a huge impact, and we produced the computer with the help of transistors. A lot of development was there. So in 1955 to 1965 is the era where the transistors and the batch systems were introduced. Then 1965 to 1980, ICs were invented, multiprogramming was introduced, and from 1980 till present, such a rapid change that we put up everything in one basket, and we call it as the 4th generation or the latest generation of the computer system. हो सकता है फ्यूचर में हम इस era को भी किसी जगह पर split up करें, लेकिन हम 1980 onward को, जब से ये पर्सनल कंप्यूटर्स आए हैं, हम इसको एक ही कैटेगरी में फिट इन कर रहे हैं. मे बी आज के दौर में we have invented palm top tablets or mobile phones. We may call it as the 5th generation, but up till now we call it as the part of the 4th generation. So let's take all these generation one by one. The first generation was vacuum tube. Obviously it's the from mechanical to shift to the electrical and electronics. So a professor John built first functional digital computer at Iowa State University, USA. So it used 300 vacuum tubes. In the same time, few other professors produced the computers using relays. It's an again electrical device at Berlin, Germany. In 1945, the group at Bletchley, England, they produced Colossus. That was the start of the era. And at the same time, the Mark I was also built at Harvard University. So the ENIAC was built by William Mashway and his graduate students. So this was basically the era where the computers were started coming up, and those computers were usually built up with the vacuum tubes. What type of computers were those, and what were the features of those computers? Obviously it was a huge machine comprising few 100,000 vacuum, 100,000 to 200,000 vacuum tubes, and basically वही इन्वेंट कर रहे थे, वही उसको ऑपरेट कर रहे थे, वही डिजाइनर थे, वही प्रोग्रामर थे, वही ऑपरेटर्स थे. So there was just one single group who was doing that, and the computers were programmed with the help of electrical circuits, और उस electrical circuits को हम कहते हैं plug boards. So the people first build up their instructions on the plug boards, then they request the computer systems, that the whole computer system should be allocated to them. Then they insert their plug board with the computers and pray that during the execution of their circuits कोई ऐसा ना हो कि 20,000 वैक्यूम ट्यूब में से कोई ट्यूब बर्न आउट हो जाए और फिर उनको दोबारा जीरो से स्टार्ट करना पड़े. In early 1950s, the punch cards were introduced. Punch cards आ गए and it was possible. अब punch card जो थे were used to instruct the computers. आप अपनी instructions को punch card के ऊपर punch कर सकते थे. So basically they replaced the plug boards and it was the stable you can say technology than the plug boards, and the people had started using the computers. And the computer soon became the reliable machines, and they were manufactured and sold. But obviously they were very, very expensive, and so when I say that they were sold, तो इसका मतलब है कि एक सेपरेशन आ गई. मैंने आपसे कहा था स्टार्ट में डिज़ाइनर भी वही थे, मैन्युफैक्चरर भी वही थे, यूज़र भी वही थे और उसके इन्वेंशन भी वही कर रहे थे. बट लेटर ऑन when the computer started selling out, तो manufacturer separate हो गए, designer and manufacturer were separate, and they were the organization who has the facility or who purchased those computer has this hired the services of the operators, programmers, and the maintenance team that could operate, maintain those computers. So these computers were called the mainframe computers, which were operated by the professional operator, not by the ordinary users. And only big companies and organizations were able to afford that because it costed very high. Multi-million US dollars were spent on purchasing one single machine, a computer. So how the job was run on the computer, very interestingly, as I said, that the punch cards were there. So the user write the programs on paper and punch it onto the punch cards and then submit these cards into the computer room. I started my career in 79, 80, and at Quaid-e-Azam University, we used to have these punch machines. So we use the punch machines, write the programs in Fortran language on the paper, then put the paper side of the punch machine and start typing each and every instruction, one instruction per one punch card. And then we had the set of few punch cards and looking into the computer room to Zahur Badshah, our operator, and request him that please execute our job at the earliest. So basically the punch cards were submitted into the computer rooms where the professional operator take that card and load it into the computer and execute that. If the Fortran compiler is needed, so Zahur Saab used to walk to the cabinet, वहाँ कैबिनेट खोलते थे, फाइंड आउट करते थे कि कोबाल का कंपाइलर है, ये फोर्ट्रान का कंपाइलर है, ये PL1 का कंपाइलर है, which compiler is required. उस कंपाइलर को used to take out on a spool of tape and loaded it onto the computer, and then this compiler is provided to the user. So all manual, but obviously onto the computer. So the much computer time was wasted while Zahur Saab was walking around in the computer center, and we were as a student waiting outside and praying that our job will run in the first go. No syntax error, no semantic errors are there. Then came the improvement into the system, and by the way, the computer that were provided that were processing the programs were 7094 machines, which the operator used to handle that. But there came the machine which was 1401. This machine used to read the computer programs, into the tape. Now, instead of picking up all those decks, the punch card decks, instead of putting them all by the card reader, all those are placed into, although placed into the card reader, but they are read and placed it onto the tape. क्या करते थे कि वो सारे स्टूडेंट्स के और पूरे ग्रुप के जो पंच कार्ड्स थे जिसमें उनके प्रोग्राम्स होते थे उसको रीड आउट करते थे और उसको रीड आउट करते थे एक सेपरेट कंप्यूटर के ऊपर एंड प्रोड्यूस द टेप टाइप मचाने के लिए. फिर carry that particular tape onto the main computer 7094 and loaded that particular tape where the data one by one is read and processed by the machine and the output is once again saved onto the tape so that कि उसको प्रिंटर और कार्ड पंच जो कि बहुत स्लो डिवाइसेस थी उसको हर प्रोग्राम को हैंडल करने के लिए मेन कंप्यूटर को एंगेज ना करना पड़े. फिर ये आउटपुट टेप जो है 7094 से जाने के बाद दोबारा 1401 कंप्यूटर पे जाती थी जिसके ऊपर एक प्रिंटर अटैच होता था और वन बाय वन जो आउटपुट है वो उस प्रिंटर के ऊपर प्रिंट आउट होती थी. उधर से कार्ड डेक उठाया, उधर से आउटपुट उठाई, इट इज रिटर्न बैक टू थिंग. सो देयर वर वैरायटी ऑफ मशीन्स. ये 1401 की कैरेक्टरिस्टिक्स थी कि वो द कैरेक्टर डिवाइसेस को ऑप्टिमली रीड राइट किया करती थी और जबकि 7094 वाज अ मशीन विच वाज गुड फॉर द साइंटिफिक पर्पसेस, फॉर द हाई स्पीड कैलकुलेशंस वर कैरिड आउट ऑन 7094. ये वो era है where we used to have dollar job. I still remember my roll number. It was dollar job 006007 Ahmed Mumtaz Mustasan. So that was the identification, and then we used to request that we need, I need Fortran compiler. Then place my program over there. Then if the program is successfully compiled, then it is loaded. The object code of the program is loaded, then it's executed, and the data is also provided at the end. So in the form of cards, so it is picked up from there, and $end means end of execution. The same thing has been explained here. The job card specifies the maximum run time and the identification of the person and the rates to be charged. Obviously, we were a student, so no charging. So $Fortran card tells the operating system to load the Fortran compiler from system tape. $load card direct the operating system to load the object program just compiled. If it is, of course, there is a syntax error, no object code were produced and the job is failed and returned back to the user. But if it is successful, then the run card tells the operating system to run the program with the data that has been provided in the form of cards, and then the $end card ends the execution. Then came the third generation. In fact, I did, as I said, in my master's in 7980, but still there were punch cards available. So there came the era which was the era of ICs and multi-programming. IC stands for integrated circuits. Silicon chip introduce हो गई और बहुत reliable computers बनने लगे. Second generation में there was a problem of compatibility. 7094 was world-oriented, large-size scientific computer. मैंने जैसे कि भी आपको बताया कि वो scientific calculation के लिए use होता था. Whereas 1401 was a tape sorting, printing by banks and insurance companies, or was also used to read out the card decks, or it was also used by the organization doing working in the commercial areas of the like banks and the insurance companies. So IBM introduced IBM 360, a series of software compatible machines which were compatible on with both 1401 के साथ भी compatible था, and the machine were also compatible with 7094. So the 360 was the first major computer line to the users. Small scale integrated circuits providing a major price performance advantage over the second generation machines. So बहुत सारी organization जो है, they have started procuring the machine. So all machine, there was series of IBM 360 machines, and all these machines have the same architecture and instruction set. What does it mean? It means that the program compiled on one machine could be able to execute onto the other machine as well, because उसका architect same था, उसका instruction set same था. So 360 was designed to handle both scientific and commercial computing. So it was too much. They offered that they will provide the compatibility and they will provide all sorts of services, whether it's a scientific application or whether it's a commercial application. So IBM came up with the subsequent machines also, 360 के बाद 370, 4300 and 3080 and 3090. By the way, I just recalled the model of the computer we used to have at the at Qaid-e-Azam University. It was IBM 360 G44. IBM 360 G44 machine was there in Qaid-e-Azam University in 1979-80. So the descendant of these machines are still available. आज के दौर में भी जब ये दोबारा से revive हुआ है, the internet आया है, तो World Wide Web में being a server, they can provide or they can handle thousands of requests per second, which of course a PC or personal computer cannot do that, because that is not the mainframe machine. So that mainframe machine have got another use very recently and very latest. So the greatest strength was one simple architecture for variety, and that greatest strength of the computer was basically the greatest weakness also, because IBM tried to provide the compatibility for everything. They tried to provide the compatibility means they put indirectly a lot of pressure onto the operating systems. Means the operating systems are now required to undertake a variety of application. The result was enormous and extraordinary complex operating system. Probably 2 to 3 times of the magnitude of larger than FMS. FMS was a very popular operating system, but just because of this compatibility issue, उसका operating system का size बढ़ता चला गया, and it was difficult to handle at one stage. So each new release fixed some problems, resolved some problems, and introduced some new problems. So end of the day, number of problems उतनी ही रहती थी. जितनी problem solve करते थे उतनी ही introduce हो जाती थी, directly or indirectly. So that it was a big headache for the IBM. But the good thing was that this era introduced a concept which is called multi-programming. This generation introduced this multi-programming just because it was possible to have multiple programs simultaneously present into the memory of the computers. So you can put in 3, 4, 5, 10 jobs simultaneously in the memory of the computer, and it was only possible because there was a invention in the hardware and there was a protection hardware was available. Protection का मतलब कि एक job जो है that could be protected from the second job and the second job be protected from the third job. So just because of this protection hardware, it was possible to load multiple jobs simultaneously into the memory of the computer. So when we load multiple jobs simultaneously present in the memory of the computer, and if one of the job is blocked because it is waiting for the IO, the CPU could be handed over to the second job. उसका फायदा क्या होता कि CPU की utilization बेहतर होने लगी. Second job stuck up हो गई with some IO or with some something, the CPU was handed over to the third one. The CPU was handed over to the fourth one. अब ये हैंडिंग ओवर कैसे हो रही है और ये सारा कुछ है, विल टॉक अबाउट इट इन लेटर, लेकिन एट दिस स्टेज आप सिर्फ ये समझें कि मल्टीपल यूजर्स और मल्टीपल टास्क जो थे वर अवेलेबल इन द मेमोरी, और सीपीयू बड़ी तेजी से वन आफ्टर द अदर उन टास्क को एलोकेट किया जाता था, और एवरी यूजर हैड गॉट अ सफिशिएंट अपॉर्चुनिटी एंड टाइम टू कैच होल्ड ऑफ द सीपीयू एंड एग्जीक्यूट द जॉब. This simultaneous loading of the job introduced a concept which was called spooling. The ability of the system to read the job from cards to the disk simultaneously. जो स्टार्ट में मैंने आपको बताया था कि आपको पंच कार्ड्स पे कि आप साथ इनपुट दिया करते थे, और फिर बाद में ये पंच कार्ड जो हैं वो आपके रिप्लेस हो गए, और फिर आपका इंटरैक्टिव यूजर्स आ गए. और एक फायदा ये हुआ कि अब मल्टीपल टास्क जो है ना वो साइमल्टेनियसली कहाँ से मिलेंगे. ऑब्वियसली मल्टीपल टास्क साइमल्टेनियसली लेने के लिए वी हैड टू हैड अ डिवाइस विच इज कॉल्ड अ डिस्क. सो डिस्क के अंदर ये कैपेबिलिटी थी कि आप उसके अंदर मल्टीपल जॉब्स को लोड कर देते थे, और फिर इन जॉब्स को आप मेन मेमोरी ऑफ द कंप्यूटर के अंदर ले जाते थे. सो द एबिलिटी ऑफ द सिस्टम टू रीड द जॉब फ्रॉम कार्ड टू द डिस्क, इवन इफ यू आर यूजिंग द कार्ड्स, अगर आप कार्ड से भी यूज कर रहे हैं तो उससे पहले डिस्क में चला गया, और फिर डिस्क के साथ आप उसको मेमोरी के अंदर ले गए. सो द साइमल्टेनियस पेरिफेरल ऑपरेशन ऑनलाइन इज कॉल्ड द स्पूलिंग. द कॉन्सेप्ट ऑफ मल्टी प्रोग्रामिंग के अंदर स्पूलिंग की मदद से हम कामयाब हुए. एंड आई एक्सप्लेन इट, आई अंडरस्टैंड इट्स अ बिट ट्रिकी एंड बट आई विल कम बैक टू दिस लेटर ऑन. Then there was another concept which is called time sharing. This is a variant of multi-programming which is called time sharing, in which each user has an online terminal. अभी जो थोड़ी देर पहले मैंने आपसे बात की थी कि अब बजाय इसके कि कार्ड्स जो थे कार्ड्स वर वैनिश्ड, और फिर अब आपके पास टर्मिनल्स आ गए, और टर्मिनल के ऊपर आपके पास साइमल्टेनियस यूजर्स जो हैं दे आर प्रेजेंट. Hundreds of users could simultaneously be able to one computer. अगर मशीन बहुत स्लो हो, as slow as we got X11 780, it was just simple one MIP machine. One MIP means 1 million instructions per second execute कर सकते थे. अब अगर 1 million instruction per user हो, और अगर आप अज्यूम करवें देर आर 100 साइमल्टेनियस यूजर्स अवेलेबल हैं, और 100 यूजर्स का मतलब है कि ईच यूजर कैन एग्जीक्यूट 10,000 इंस्ट्रक्शंस. ओके, और 100 into 1,000, 100 into 100,000 is 1 million. So 10,000 इंस्ट्रक्शन एक सेकंड में एक यूजर की एग्जीक्यूट होती. So basically even if the CPU के टाइम को भी हम कंसिडर करेंगे, एक यूजर से लेके दूसरे को दे रहे हैं, दूसरे से लेके तीसरे को दे रहे हैं, there was a bit wastage. Even then the speed of executing the number of instructions per second was very high, and that has resulted in the time sharing concept, interactive users का time sharing concept. So the time sharing system, CTSS, compatible time sharing system, was developed at MIT on a specially modified 7094 system, but did not become popular until मैंने आपसे कहा था कि वो हार्डवेयर प्रोटेक्शन उस वक्त अवेलेबल नहीं थी. ये सेकंड जनरेशन में काम शुरू हो गया था, लेकिन थर्ड जनरेशन में जब हार्डवेयर प्रोटेक्शन हमारे पास अवेलेबल हुई तो फिर इट वाज सक्सेसफुल. So after the success of CTSS system, major computer manufacturer decided to develop computer as a utility. For example, बोस्टन में डिसाइड किया कि 1 computer for everyone in बोस्टन जो है वो हम प्रोवाइड करेंगे, और उसके लिए एक ऑपरेटिंग सिस्टम होगा जिसको हम मल्टेक्स का नाम देंगे. So Multex had a mixed success. There were many reasons कि वो मल्टेक्स सक्सेस नहीं हुआ. उसकी वजह ये थी कि ओवर एम्बिशियस था, और इट वाज डेवलप्ड इन PL1. PL1 बहुत जल्दी ऑब्सोलीट हो गया. इट वाज नॉट सक्सेसफुल. द साइज ऑफ द मल्टेक्स वाज वेरी लार्ज, और ऑब्वियसली इसकी वजह से उसकी प्राइस बहुत ज्यादा थी. The major reason of the failure of the Multics was basically its price. So Multics introduced many ideas. ये सारी चीजें डेवलप होती रही और हर एक जो भी इन्वेंटर आता रहा, जो भी ग्रुप आता रहा, वो नए नए आइडियाज प्रेजेंट करता रहा. सो मल्टेक्स में भी बहुत सारे आइडियाज आए और मल्टेक्स इंट्रोड्यूस मेनी आइडियाज इनटू द कंप्यूटर लिटरेचर डिस्पाइट ऑफ द लैक ऑफ कमर्शियल सक्सेस. सो द मल्टेक्स हैड अ ह्यूज इन्फ्लुएंस ऑफ द सब्सिक्वेंटली प्रोड्यूस्ड ऑपरेटिंग सिस्टम. बाद के आने वाले ऑपरेटिंग सिस्टम में बहुत सारे मल्टेक्स के कॉन्सेप्ट थे जो कि यूज किए गए थे. So the concepts of computer utility had fizzled out but came back very recently. जब हमारा इंटरनेट आया तो उसके अंदर ये बहुत सारे concepts वापस आ गए. So before I just conclude that, I would like to also touch upon the Unix and Linux. Ken Thompson, one of the professor, got hold of one PDP-7 mini computer, unutilized पड़ा हुआ था, and he decided कि ना वो Multics का single user version produce करते हैं उसके ऊपर. तो he decided to produce a single user version और later on वो उसकी जो attempt थी that had resulted in a very famous and popular operating system of nowadays, which is called Unix, which has a slightly variant version or slightly different flavor in the form of System 5, in the form of Berkeley software distribution, in the form of Linux or Solaris. So basically that was an attempt that was made by the Ken Thompson और उनका एक शागिर्द था, I don't remember his name, Richie. I don't remember the whole name, but he was Richie. So Thompson and Richie produced Unix operating system, and not only this Unix operating system, pehla version they produced it in assembly language, and later on they produced another language जिसको उन्होंने नाम दिया B language का, and produced the Unix version on that. Then they finally, it was highly popular among different organizations, so decided to build up a commercial Unix operating system. So they decided to improve the B language, and then they produced the higher version of B language and named it as a C language. So उन्होंने ना सिर्फ ये कि Unix produce किया, but they also produced a very popular language of nowadays, which is the C language. और C language के अंदर Unix को produce किया गया. फिर Unix के different flavors आने लगे, those were incompatible. Then the IEEE decided that there should be certain standard, and IEEE introduced a standard which is called POSIX. And whatever operating system has followed this POSIX had resulted in an operating system that has a compatibility. Basically क्या किया कि POSIX ने एक सिस्टम कॉल को स्टैंडर्डाइज कर दिया. जब सिस्टम कॉल को स्टैंडर्डाइज कर दिया POSIX ने, तो जो लिनक्स है और यूनिक्स है उनकी आपस में कंपैटिबिलिटी आ गई. तो आई थिंक this is more than sufficient. I advise you to please go through all these details and forget about the technicalities that you find out in the first chapter. As I have already promised, that will go one by one in detail in the subsequent chapters. Just read it out and enjoy the history of the operating system. So with this, we conclude this particular lesson, and I'll come back to you with the next lecture, inshallah, very shortly. Till then, Khuda Hafiz, Azani ke baad.